All right. So, hello, everybody who's with us currently. And for those who will join momentarily, we are recording the session today. I'm Ken Jackson. Welcome to the webinar on future-proofing Industry 4.0 initiatives with private 5G. I'm the AVP of private 5G sales with Tech Mahindra, and I'm joined today by my colleague Alex Besen, who's the CEO and founder of the Besen Group. We've got a lot to cover today, so we want to go ahead and get started. We're going to begin with a couple of survey questions that we'll post up here in a minute and ask for some participation to get those answered. I will then go into the Tech Mahindra side of the webinar today, focusing on Industry 4.0 transformation, the business drivers around that, how private 5G is critical to achieving those business drivers, a little bit on our 5G offering from Tech Mahindra as a single source end-to-end provider, and cover a few references and success stories. I'll then turn it over to Alex. He's going to do an overview of his company's total cost of ownership and return on investment tools focused around private 5G implementations, and give us an exciting demonstration of his soon-to-be released tool for auto manufacturing ROI. During the presentation from both Alex and I, feel free to type any questions into the chat. However, we will wait until both myself and Alex finish our presentations, and then with the remaining time, we'll do our best to get through as many of those questions as possible. Also, please note, we will include copies of the slides. They'll be mailed to everyone who registered, along with a recording of the webinar. So with that, let's go ahead and start with our survey questions. So if we can have the first question presented, please. Okay, there it is. So who do you think will be the best partner for enterprises to launch private 5G networks? We've got 4 options there. Appreciate you taking the time to enter your responses into that poll. And we'll give it about 10 seconds here for people to respond to that. Okay, got some additional responses coming in. There we go. Things are tabulating. Looks like of the answers that we've got so far, it's a combination of mobile network operators and system integrators. I see only a few of you have had a chance to respond. We'll give it another couple of seconds, and then we'll go ahead and move on to the second poll question. Okay, well, I think we spent enough time on that. For those who were able to respond, I appreciate that. Again, it looks like it's kind of split. A couple people have also indicated radio vendors. All right, so our second survey question: what are the key success factors for launching a private 5G network? And we can get that question up. All right, again, appreciate those of you who are with us. If you can give us your feedback on that. We'll wait 10, 15 seconds, see what kind of responses we get for this question. All right, things are tabulating. Looks like the response times are taking a bit of time. All right, so looks like the majority of the people who've responded believe that all of those criteria, spectrum, ecosystem, and business case ROI attainment, are all important. So based on that, we're going to go ahead and close the poll. Thank you for those of you who participated in that. And we'll go ahead and move forward with my part of the session. So Industry 4.0 transformation, business drivers associated with manufacturing and factory production environments. So quite a bit of material here, really going to focus a lot on the middle column. There are really three main areas that we're seeing as a part of this digital transformation in regards to benefits and return on investment that are coming back to the customers that we're working with. The first area has to do with efficiencies in production and reductions in rework due to improved quality. We're seeing people who've put in automation and other factors with artificial intelligence, visual inspection, getting inspection time reductions, which results in some pretty significant quality improvements. And that, of course, helps to increase the overall production efficiency. Jumping to the bottom of the middle, we're also able to then provide visibility into that end-to-end environment, helping to refine processes, understand where backlogs and bottlenecks may be in the assembly and line process end to end, getting that feedback to you so that you can then go in and assess your setup, make changes. And again, that relates back into production efficiency improvements by getting those analytics and insights. The final area in the middle has a lot to do with cost savings. The labor savings come in two different ways. First of all, through efficiencies, but also when we introduce automation and digital transformation, some of the tasks that are manual today become automated. That in today's environment is often a positive thing because of the challenges in getting skilled labor is one of the biggest problems that most of our customers are facing. When we reduce the quality issues, we also have less rework, which includes a reduction then in inventory costs. And then through predictive maintenance and other aspects of digital transformation, we also can help keep things running efficiently. And when you've got a near 100% uptime in your line, you then clearly have savings that are resulting from a reduced cost of maintenance. So these Industry 4.0 transformations, they have a number of different implications. There's several different use cases. We're going to touch on a number of these things as we go forward here today. So what about this private 5G? Why is it critical to achieve these business drivers? Well, first of all, I just want to talk about 5G overall. A lot of people believe it's mostly hype. There is a reality to the fact that we are now coming into mass adoption, and especially when we start talking about private 5G in the enterprise environment, we have the ability with the ecosystem and devices that are now coming to market to be able to bring in applications and use cases that previously were only possible through Ethernet and fiber type cabling or just weren't possible in the environments. There is a capability of speed, a very low latency component, and a very high bandwidth. We're now attaining over gigabit speeds using cellular wireless with private 5G. That just wasn't possible in previous versions of cellular technology. So in the triangle, we see a number of these different use cases we're talking about today that can be implemented within your manufacturing and factory environments and allow you to not only increase that production, increase worker safety, reduce quality problems, get insights, some of the things that were mentioned on the previous slide. But why not just stick with Wi-Fi? Well, you're not going to replace Wi-Fi. I think that's one of the most important things to realize. We're not talking about a rip and replace of Wi-Fi. Wi-Fi certainly has a purpose, but it's more of an IT technology. It's leveraged for laptops and other types of connectivity. It's really not designed, especially in a manufacturing and factory production environment where there's a lot of metallic, a lot of machines. These things reflect RF waves, cause a lot of interference, and Wi-Fi unfortunately can't deal with that very well. As a result, the coverage is patchy compared to 5G, which is ubiquitous. Furthermore, there's a big reduction in the number of 5G radios or small cells that are required compared to the same number of Wi-Fi access points for the same environment. We see factors of 1 to 3 up to 1.7, 1 to 8. And what I mean by that is one 5G small cell compared to the need for 3 to 8 Wi-Fi access points. So you get a lot more coverage, but more importantly, as we move on down, you gain mobility. One of the biggest challenges with using Wi-Fi in a environment that needs handover and seamless mobility, think about AGVs, AMRs, robots, things that are constantly moving. But couple that with workforce communication systems, people moving around, needing to communicate with each other, also AR, VR, XR headsets that need to be moving all over the environment. You need those devices to be connected and be connected reliably. 5G gives you that handover, that mobility, and gives you that robust interference management and reliability. Neither of those are possible with Wi-Fi. And then dovetailing on that as we move down, the reliability, the ability to segment and create tiered services. In 5G, we can create certain quote unquote users like video cameras and give them high bandwidth. We can also create other users, i.e. robots, AGVs, and give them extremely low latency. And if they have video cameras on them, also give them bandwidth. You can't do that type of segmentation, nor can you provide a reliable quality service with Wi-Fi. But these are complementary. We put certain things on 5G, and then you can use your Wi-Fi network for other things like laptops and employee connectivity. So this is a very detailed slide. It's really more examples of what I was talking about in the previous two slides. On the bottom, we have the bandwidth axis from low to high, and on the vertical, we have latency from high to low. Some devices can tolerate high latency, but they need, and they also need minimal bandwidth. Machine-to-machine type connectivity is a good example in the lower left. Other devices in the upper right, they have high bandwidth needs, but they also have low latency needs. Anything that requires vision or video, anything that is moving, those things need a low latency, and in many cases, they also have high bandwidth. And again, through 5G, we can segment these devices and we can enable all different types of devices in the same environment connecting to the same small cells and get a very efficient use and enable these to provide that digital transformation and enable these use cases that can bring you a new return on your investment and increase your production, lower your quality issues, and increase employee productivity. So, how does Tech Mahindra fit into this? A single source as a solution provider. This slide starts to give a better picture. We're not just talking about a private 5G network. That is an underlying enabler. You need to have it plus the devices, as we see on the left side of the slide, and you need those to tie into application cloud and other internet type services, and you need to have it secure. So Tech Mahindra, first of all, is capable of bringing a number of different solution providers in. We assess which one of our solution providers is best for your needs, and then we help to engineer and design that and bring it in and deploy it, along with the device ecosystem that would then be running over that private 5G network to enable these use cases and these applications we're speaking about. That takes us to the middle. Some of these things we briefly mentioned: asset tracking, connected workers, AGVs, AMRs, robots, bringing in IoT sensors to be able to do condition-based monitoring and generate that predictive maintenance to keep all of your equipment up and running. And then finally, where Tech Mahindra also plays a role, if not obvious yet, the end-to-end system integrator of all of that, but also providing any necessary local edge compute, customization services, such as bridging in through APIs, some of these applications with some of your back office systems, such as SAP, and also making sure that this environment is secure. We want to make sure that all corporate security guidelines are adhered to. And speaking of that, 5G is very secure, especially compared to Wi-Fi. It's one of the most secure ways that you can connect devices over the air. And then perhaps the most important thing to you, you don't want to have to go hire your own cellular wireless team and augment your IT team. We provide the network operations to keep all of this up and running. Now, one other thing that Tech Mahindra can also bring to the table is where you have a multi-site environment. Most of you doing manufacturing have got multiple locations. And you may have a corporate backbone in place. That might be something you could be looking at to also save cost and outsource that SD-WAN as a service or network as a service, being able to tie together all of your locations and the applications and devices, in some cases with on-prem, but most likely also a need to go hit an enterprise cloud or enterprise data center. We work with hyperscalers, we work with private cloud, all different combinations, but we can tie all that together and also offer you as a service network connectivity leveraging SD-WAN. So Tech Mahindra is your solution provider end to end for this type of enablement. The final thing, and this is a recent addition to our portfolio, we're offering this as an optional capability for you to be able to gain insights on what's happening end to end with your network. And that would be your network from the end devices connecting over the private 5G infrastructure, moving through local compute or cloud compute, and the applications and services. We come in at the very beginning of the project, we design and engineer what's going to be required, what types of data points you're going to be looking for throughout your end-to-end network. An example could be too many hops or other things that are causing excessive latency, certain applications not performing the way that you would expect them to or need them to. We would then go and establish a test bed to prove all that out. We would deploy it along with the other aspects of the private 5G implementation. And then we would manage this piece of it, provide you with those insights and analytics, and help you to manage towards the service level agreements and commitments that are necessary to keep that environment operating the way that it needs to maximize production efficiency and those quality gains and all the other return on investment capabilities. In summary, Tech Mahindra brings you the connectivity piece, edge and cloud, again, working with all the major hyperscalers, the digital platforms, including IoT partners and applications. In many cases, those applications are developed in-house. Again, the integration capabilities through APIs to applications you may already have, as well as partners for additional applications. The consulting and the end-to-end integration, all of these things, installation and acceptance to get it going, and then the global management framework. And speaking of that global management, we have an end-to-end network operations center that all of our enterprise customers benefit with private 5G deployments. We hand off, we're 24/7 by 365. We take care of the monitoring. If there's any type of equipment issues, we dispatch and we get things fixed, and we offload you from all of those responsibilities. So the final part of my presentation is to briefly talk about a few of our success stories and some of our references in regards to Industry 4.0 digital transformation in the manufacturing and production environments. One of the biggest things, I've mentioned this a few times already, is XR, AR, VR, whether it be an AR, VR headset, a HoloLens type device. Again, Tech Mahindra has the ecosystem to bring in the hardware, bring in the software, tie this into things like back office systems where necessary, roll it out and support it. Some of the key use cases that our customers have been benefiting from with this type of technology so far: training, and then guided assembly in the manufacturing environment, making sure that people are completely familiar, especially newer employees that are still in the training process, but you need them to get out and get into the production line, trying to minimize any quality issues. This just really helps to augment and give flexibility into your staff. And then also with things like maintenance and troubleshooting, we have the ability to bring in remote expert capabilities through that AR, VR, or HoloLens, and have an expert on the far end assist the person that's boots on the ground, whether it be with fixing a problem or other types of activities. Another example of this AR, VR is training. and implementing those standard operating procedures as a part of the assembly and manufacturing process. You can't afford to send a bunch of your employees for remote training, and bringing in and suitcasing training is a bit more old-fashioned when it comes to training. Nowadays, especially with HoloLens type devices, you can have each employee go through the training at their own pace, reiterate things they need to. It results in an overall effective training that is improved and more easily implementable. They then have the ability to go and leverage that as a part of their day-to-day activities and extend that into the manufacturing environment. A lot of savings in regards to training, but also getting employees more effective, which has a cost component to it as well. Now, another key area that we're seeing a lot of traction and a lot of learning, especially as it applies to quality assurance. One of our partners is the IBM Maximo solution, but we have other partners in this type of area as well. The idea here is eliminate human inspection, leveraging digital twins and other aspects, and not just for final products. What we're showing here as a case study is an inline assembly QA, where on the left, an engine that is being able to be inspected before it's installed in a vehicle. And then on the right, a vehicle that is on the assembly line and doing spot checks on certain pieces of the assembly process up to that point. We've been working with customers since 2021, and we've seen savings of up to $60,000 a day by doing this at checkpoints along the assembly manufacturing line process. Another good example, we were working with a partner, a company that was building transmissions, and they were having issues with their gears because there were actually small defects in the gears. They were putting those into the transmissions and then having recall problems, quality issues. It was costing money. And by doing an upfront gear inspection through AI and cameras in 5G, what we found was we were able to get those defective gears out before they were used in the manufacturing process, and a resulting quality improvement, 12 to 15%, pretty significant. A couple other examples of this, having a camera on a robot, and then again with a digital twin, in this another case, automotive and engine, having that robot be able to move all around the engine and do quality inspection at different points, different angles, different sides of the engine to make sure it's ready to go into a vehicle. Moving to a different type of use case, condition-based monitoring. I mentioned this earlier in the presentation in regards to being able to help minimize equipment failure in the line, whether it's a pump or a motor or another piece of your manufacturing environment via IoT sensors and software that is measuring various different parameters customized to your environment, identifying when something appears to be getting ready to fail and being able to alert maintenance technicians to go and deal with that in a way that does not impact the production line due to an actual failure that was unplanned. A key savings that is helping to increase productivity, reduce downtime, and also, of course, reduce maintenance costs. A lot of different ROIs coming from that. A couple of final slides here. AGVs, AMRs. This example is in the warehouse. One of the things that I like to also remind my clients, a manufacturing process needs to get fed with supplies, supply chain, warehouse and inventory on the inbound side. And then obviously you've got the outbound side. And the private 5G use cases, many of which we've been talking about, can also be leveraged in that environment, not just the actual factory floor and production floor. So again, having things that can move around, not get stuck, and automate, it helps to increase employee safety and efficiency and other areas that once again feed return on investment. The final two slides are very detailed. I'm only going to call out a couple of things here. Automotive use cases. One of the areas that we've seen one of our customers get significant improvements, a 99% improvement in paint defect identification. That's by leveraging camera vision inspection and AI. It also reduced the vehicle inspection time by 50%. That allowed a significant increase in the movement of the vehicles in and out of the paint area. Another area that's interesting, an outdoor private 5G network with tough books connected to it. It's the bottom example here, ECU flashing before those vehicles are then transported to their final destination, making sure that the firmware in the vehicle is reflashed before they actually get transported. Again, we'll share these slides with you. This last piece is just another set of automotive use cases, tracking and tracing, whether it be parts or semi-completed assemblies, a lot of different viability, IoT sensors, etc. So with that, that completes my section. I'm going to turn it over now to Alex so that he can then go and talk to us about his piece of the webinar.
Thank you, Ken. Welcome, everybody. I'm going to focus on the in-depth look at the smart factory case study today. So this presentation, we have a brief disclaimer here. Besen Group LLC makes no warranties expressed or implied in the presentation. Just a background on our company. We are founded in 2004 in the state of Virginia. We are specialists in the mobile wholesale market and private networks market. And we have consultants with a hands-on experience from the US, Europe, and Asia. We offer strategic advisory, business development, market research, training services. And our clients include communication service providers, MVNOs, MVNEs, enterprises, system integrators, mobile vendors, hyperscalers, and financial institutions. In regards to private network experience, we have worked on these 5 different use cases. And we were a subcontractor to each engagement, and we work with the system integrator for each of them. And we developed a customized business case for agriculture, automobile manufacturing, smart cities, oil platform, and military base in the US. So I will tell you more about our expertise in the business cases when we come to our tools section. In regards to our strategic advisory services, we offer strategy planning, business case development, segmentation, auction strategy, partnerships, marketing product launches, market research, and project management. We also offer business development service on a retainer basis. In terms of market research, we have developed our own research last year for the US market, looking at the 5G, based on the following 14 segments, from the warehouse, office space, education, hospitality, healthcare, and public safety. Our methodology is that we get the survey data from EIA, which is a government agency in Washington, D.C., and we go through it in terms of data mining and analyzing all that large data set, and then we put our own mobile market assumptions, and then we develop the market size and market forecast for 5 years. We can also add additional segments if our clients interested, like manufacturing, energy, etc. In addition to our market research, we also develop case studies from the private networks. We have developed the following case studies from different vertical segments, from casino, shopping mall, automobile manufacturing, hospital, airports, theme parks, racetrack, shipping port, and warehouse. So for all these case studies we have developed are based on publicly available information, and we use our tools in order to determine the cost of deploying private network in each segment. In terms of our tools, we have developed US mobile industry's first business case and TCO tools for private LTE networks, private 5G networks, and niche loss networks. Today, we have 12 tools. We have 3 business case tools, and we have 12 TCO tools. And we are going to release our 13th tool dedicated to the automobile manufacturing this fall, based on the private 5G networks. We can tell you that with our tools, especially with our 5G spectrum tool, we can calculate the cost of any indoor, outdoor private 5G network in less than 10 minutes. So it doesn't matter, what size. We plug in the data into our tool. We collect some of the bandwidth consumption from our enterprises, and then we can then run the tool and then come up with the cost for capex and opex. So the business case tools, they include TCO. So that means that they include market size, capex, opex, TCO summary, revenue statement, income statement, depreciation, valuation, and some summary graphs. TCO tools, they just include the market size, capex and opex, and TCO summary and the summary graphs. So we offer our tools on a corporate license basis to our clients. We can also develop customized tools based on a client requirements, or we can modify our tools based on the client requirements after they license it as well. In regards to our training, we offer the following 3 different private network seminars: the private 5G, private LTE, and CBRS. We host our seminars on a private at our client locations, or we do a partnership with the key industry associations such as GSMA, WIA, to host our seminar at the annual trade shows. So we have one coming up next week at the Connect X. We are hosting a CBRS workshop, and then we'll be hosting a private 5G seminar at MWC in Las Vegas in September. So if you are interested, please let me know. So we're going to talk about the private 5G business case methodology now. For our new tool, again, this is dedicated to automobile manufacturers. So the way we have modeled our tool, we look at the factory size, and we develop some use cases and assumptions. The use cases, we can get it from the factory, from the enterprise, or we have, for our tool, we are doing it now on a generic basis based on the 5 different use cases. And then we can able to select this 5G spectrum. We can have a low band, mid band, high band. This is the global, right? So it doesn't matter if you are in Asia or in Europe or in the North America, we can select type of spectrum that you want to deploy this network. The low band spectrum covers between 600 megahertz to 1 gigahertz. The mid band spectrum covers from 1 gigahertz to 6 gigahertz. And the high band spectrum covers from 12 gigahertz to 48 gigahertz. Once we select the spectrum, and then the tool, we calculate this number of small cells, number of devices, and number of bandwidth. And then we have then calculate the capex statement, the opex statement. Then we'll have the summary, the total cost of ownership summary, and then we calculate the opportunity cost. We have not included opportunity cost in other tools as well. So this is a new tool, and we are including it because we can have some historical data from a factory where without deploying this private 5G network. So opportunity cost, just wanted to give you a definition. It is a concept in economics that is defined as those values or benefits that are lost by a business or business owners or organizations when they choose one option or an alternative option over another option in the course of making business decisions. Opportunity cost can be used as a trade-off. Trade-offs happen in decision-making when one option is chosen over another option. So basically, the opportunity cost is sums up the total cost for that trade-off. Okay, you will see that in the example today. So let's look at some of the network private 5G use cases. So I assumed that the need for the private 5G network at the automobile manufacturer is to increase efficiency, productivity, and sustainability. The solution we come up with is to deploy this private 5G network over licensed spectrum in order to optimize efficiency, productivity, and long-term sustainability. So the impact that we will have is to lease the licensed spectrum for reliable wireless connection for real-time communication between machines and robots, and solve all connectivity issues, including latency, insufficient bandwidth, and speed. So we estimate the opportunity cost is around 3.6%, and operational cost savings is around 6%. So in terms of use cases, we have identified the following: the operating robots, factory automation, driverless vehicles inside the factory, artificial intelligence systems, big data analytics with edge computing, and embedded cameras and sensors. So for each of these use cases, we can now in our tool assign a consumption. So that way, our small cell dimensioning engine, we calculate the number of small cells based on these use cases. So this is a sample here. So these are the use cases on the left side, and these are the bandwidth consumption for each of them. To have it simple, we came up with this same data for each, but you're looking at in terms of how many gigabytes of data we get from each use case. Okay, this is a requirement in order to calculate the number of small cells. Right? Now we look at the dimensioning of the network. So based on that, we selected the mid-band spectrum for this is on the, assuming this is in the US market, we selected that on the CBI spectrum, and then so basically our tool calculates we need 100 small cells in order to deploy this private 5G network in a factory. How many number of devices? We have 6,667 devices we have needed to cover in the factory as well. So we assumed that this deployment will be on-prem. Our tool, you'll be able to select, if you want to do it on cloud, or you can do it as a pay-as-you-go or managed service. We have 20 different scenarios you can choose from how you want to deploy this network. But for simplicity perspective, today we selected let's do this on-prem. So we'll look at the CapEx calculation. We have the indoor small cells, the installation, materials, switching, building survey, network design cost, and we don't have any license fee costs. In this, we are going to, the license fee will come on the OpEx as a wholesale lease cost. And we have the equipment cost, and we have the power installation cost, and we have the 5G on-prem cost. So it comes up to around $1 million. Okay. In terms of the OpEx, then we have the SaaS because we are deploying this on the CBI spectrum in the US. Again, if you want to use the tool in Europe and Asia, you basically don't select this SaaS option in the OpEx. We have chose the hardware software maintenance, network operations management, MNO 5G connectivity. We didn't choose that. We chose utilities, backhaul, edge computing, and wholesale spectrum wholesale from the market. The one thing I have to point out is the AWS. Our tool includes also AWS pricing. So if you wanted to deploy on AWS, you have that option as well. So you're looking at the OpEx on a year about $276,000 for. And then once we have the OpEx, we have now the total cost of ownership is about $1.3 million, right? Looking at the first year. So that represents about 21% of OpEx, 79% of CapEx. This is on the first year, right? So on the CapEx breakdown, the highest line item will be the on-prem network, core network. On the OpEx breakdown, the largest line item will be on the spectrum, the list of the spectrum. And then in terms of the on-prem OpEx calculation, you're looking at $106 per device, $41 per device, and a total TCO of $202. So what we have done, we look at the KPIs now in terms of the dollar per square footage. It's going to cost about $2.06, and then it's going to cost about $309 per device and $1.72 per gigabyte to deploy this private 5G network on-prem. So now we look at the opportunity cost. So the current factory that does not have any private 5G network is about the gross margin about 33%. Once they deploy this private 5G network, the gross margin increases to 35.6%. So in terms of the dollars, the current factory has $5 billion in the current factory. With the smart factory, that gross margin increases to $5.5 billion. In terms of the capacity, The current factory is about 250 automobiles that they produce annually. That the production will increase to 257,000 in a smart factory. In terms of the operational cost value, that's the value that's been created by the smart factory, on a yearly basis, that we can provide that information as well. It's $442 million in the first year, goes up to $518 million in the year 5. So, and then in terms of the cost comparison, we have the on-prem. So we have $7,500 incremental vehicle production. We have the opportunity, the cost value is about $452 million. And then we deduct the smart factory TCO, which is the $1.3 million. We have net value credit is about $450 million to deploy this private 5G network. So for more information, I'll invite you to visit our website. And then please let me know if you have any questions in the Q&A. Thank you.
Thanks, Alex. So at this point, go back to this splash screen here, but we'll go into Q&A time here. And so if you have not actually entered any questions, but you have something that you'd like to put into the chat, we'll go ahead and ask you to do that at this point in time. Actually, I'm going to have to go back out of slideshow mode simply because I can't see the chat. So sorry about that. Basically, all right, sorry about that. So what we'll do is we'll tag team between Alex and I, and like I said, if you have anything that you'd like to post from okay, we know we've got some questions coming in. Okay, so yes, there will be a replay available. Mentioned that at the beginning. If you join late, we'll be emailing copies of the slides, and we also will be sharing a link to a recording of the webinar for everybody who registered. All right, so we'll go into Q&A time. Alex, I guess I'll go ahead and ask you a question first, and we'll go back and forth. So if we've got anyone who wants, okay. So if you do want to speak, you can raise your hand, but otherwise we'll go with chat. That might be more effective to just write things into the chat versus getting people to speak. I've got only about 15 minutes left here for Q&A. So Alex, appreciate you joining today and sharing your TCO tools. How long do your strategic advisory projects typically last, Alex?
They last around average 4 months, Ken.
Average of 4 months. Okay.
Yeah.
Okay, so it looks like we've got a question coming in. Private 5G is Wi-Fi replacement. I think it's better alternative, or Wi-Fi not the replacement. What's your opinion? Sure. So I'm going to kind of bridge that into a couple of things here and provide an answer on that. So first of all, I don't think anybody is going to 100% replace Wi-Fi. What we're talking about, and I mentioned this earlier in my presentation, is an overlay with a private 5G network in the same environment, and then selectively moving certain devices and use cases that either were previously wired with Ethernet or fiber, or attempting to use Wi-Fi and struggling with that. We know of a number of factories that have attempted to put AGVs, AMRs, and robots on Wi-Fi, and it's been a bad experience. Even densifying down to every 40 feet with a Wi-Fi access point still does not solve a lot of the problems that we have, because Wi-Fi does not support mobility. So as a result, you would have both of them in your environment, but it would be a selective transition of certain use cases and devices over to private 5G to enable new aspects of Industry 4.0 and digital transformation. Again, I had the slide and it talked about various different things that 5G does that Wi-Fi doesn't do. So I'll also refer back to that, and you can look at that when you review the material going forward after the webinar. Um, okay, so question for you, Alex. Your tools, they're applicable for both in the US as well as globally, I believe. I think you touched on that, but just thought that I would ask a clarifying question if any of our audience is not US based, or maybe even somebody may have heard of CBRS, but they're not sure about that technology. Your tools can also be used with licensed spectrum, I believe, too. Can you just touch on that briefly?
Yes, correct, Ken. We developed our tools initially for the US market, but beginning of this year now, our tools now become spectrum agnostic, so it can be used anywhere in the world.
Okay, great. So, got a couple of questions that are sort of interrelated that I'll take next associated with Spectrum. So I think there's a couple of different things to talk about, especially when we're looking at private 5G. The big difference here is the enterprise is in control of the private 5G network, not a mobile network operator, at least in countries where that's possible. We're seeing governments, PTTs, and regulators like the Federal Communications Commission in the United States. We're starting to get more and more places where unlicensed, or in the case of in the US, shared spectrum, which falls under CBRS, has become available and can be used within the enterprise environment without having to pay a licensing cost for the use of the airwaves, the spectrum. Now, different spectrum has different use case implications. For example, millimeter wave, which currently is only available through licensed spectrum, gives you gigabit plus speeds, but today in most countries, you can only access that if you're working with a mobile network operator that has licensed that spectrum. So you then have a different type of a paradigm where you're working with a mobile network operator, and Tech Mahindra does have partners to do this and effectively leverage their network in your environment. Different operators have different ways of doing that. However, in other cases, especially when either unlicensed or shared spectrum is available, then you have the ability to completely control that environment. You're not dependent in any way, shape, or form on a mobile network operator, and you can run all the bandwidth you want. There's no extra cost involved in operating that once you spend the CapEx or amortize the CapEx over 3 to 5 years as an OpEx. I'll also just briefly touch on that. Tech Mahindra offers both as a service, where it could be 100% OpEx over 3 to 5 years, or a hybrid to that, where you would spend CapEx up front to effectively invest in the infrastructure required to put this in place, and then there would be a monthly OpEx cost over that 3 to 5 year time frame. So I think that that covers a few things. Back over to Alex. Alex, are you looking to add any additional industry segments as you move forward? I know your automotive tool you're coming out with later this fall that you gave us the sneak peek on. Are you also looking at market size forecasting, things like that?
Yes, starting this year, Ken, we're going to develop the tools dedicated to each vertical segment. Yeah. So we are starting with automobile manufacturing segment first, and I believe next year you might develop a tool for healthcare.
Very interesting.
Yeah.
I see there was another question from Mike that was a little bit more focused on penetration of spectrum and distances. So again, this goes back to indoor versus outdoor, and in a lot of manufacturing and factory production type environments, we are talking primarily indoor use cases, although I mentioned the need, in my opinion, for logistics, inventory, warehousing on both the inbound and the outbound side. There could be loading docks involved and other things. So you may have scenarios where you have some outdoor radios. I also mentioned the ECU flashing use case at one of our automotive customers. That's 100% outdoors. So you do have the ability to put these private wireless networks both in building and outdoors. There are many times implications and differences between how you do that. But the spectrum used does vary in regards to distances and penetration. I mentioned millimeter wave, which is where you can get very high bandwidth, but its propagation is less. The higher you go in the frequency band, the shorter your propagation distance is. When you go down into lower frequencies, the spectrum will travel further. But in an indoor environment, part of what we do is a part of this end-to-end process Tech Mahindra offers as your one-stop shop for private 5G. We'll come in and we'll do a site assessment, a site walk, a site survey. We understand the environment, and we then go and do an RF propagation study based on your environment, the equipment that's in it, other factors such as concrete walls in the middle of the building or other various things that will inhibit some of that RF propagation. So there is not a straightforward answer in regards to distances and how spectrum is used. There's also, I'll dovetail that with a question from Nitin in regards to OT network and machinery working with different controllers and IoT gateways. So what we're seeing customers do, of course, you're not going to go and replace that machinery with 5G enabled machinery. Even things like AGVs and AMRs, we've got adapters, and I mean, you mentioned Nitin IoT gateways. We've got ways that we can adapt a lot of the equipment and infrastructure you have invested in today and move it over to these private 5G networks, IoT gateways, Ethernet gateways, a number of different things that can stay mobile or be fixed, and use the 5G network as the backhaul, or just convert them from Wi-Fi or cables and get them onto that 5G network. In some cases, that enables you to move things around without having to go through a shutdown that includes a recabling of things. Okay.
Ken, I'm going to answer this question coming from Russ. What US markets or industry segments are adopting private cellular? So based on our market research, we believe that the top segments today is a fixed wireless access. And then we have the public safety, like a company like FirstNet, one of the largest private network in the US. And we have also the government agencies are deploying private cellular at their facilities. And so these are the top three, I would say, largest segments today.
Great, thanks, Alex. So Ross has kind of got two intertwined questions. He was saying, do you feel private cellular adoption is use case driven? And then the other thing that was going along with that is the device ecosystem and where things are at for 5G standalone. So first of all, I don't believe that anybody, whether it be a CIO or head of OT network engineering operations in a manufacturing factory production environment, is going to go spend money on 5G just to claim that they've got a 5G network. Of course not. It's very much use case driven. The ROI is a big factor around, in my opinion, coming up with several use cases that would go in roughly at the same time. Of course, you may start with one and then add a second, third, fourth, but where you really can reap the benefits of a private 5G network beyond some of the things like just enabling greater productivity through mobility and other types of things that I mentioned earlier in my presentation, is by stacking a number of use cases and then leveraging the ability for the 5G infrastructure to come up with those different network slices, as it's referred to in 5G. Different applications, different use cases, different devices, segment them out. In some cases, there may be common profiles as you add use cases. But if you're going to do vision-based quality assurance, like some of the use cases that I mentioned in my slides, you're clearly, if those cameras are going to be 5G cameras, you're going to need bandwidth and low latency, right? We've got one use case that is Tech Mahindra implemented that is being implemented in loading docks. And when you're moving inventory on and off trucks, making sure that things are not damaged. And, you know, as a forklift is bringing things in and out of the truck trailer, automatically inspecting, making sure it's the right thing coming off or the right thing going on. You need very low latency on-prem compute, as well as the ability to segment the different components of that end-to-end application and use case. So Do you need millimeter wave for all of these things? Absolutely not. There's a lot of things that can be enabled with mid-band spectrum and in some cases even low-band spectrum, depending on what country you're in and what spectrum is available for use with private 5G networks. Now, the device ecosystem, yes, for 5G standalone, it is evolving. We are seeing devices come to market now. A lot of it has to do with the form factor. The smaller the form factor, the less we have in the ecosystem today. Our friends at Qualcomm just recently introduced the X35 chip, which is a very small form factor, and that's what we've been waiting on for things like AR/VR headsets to be able to embed a 5G module into them versus a 4G LTE module. There are 4G LTE modules in various different form factors today, but the 5G ecosystem is coming to market, and throughout the rest of this year, I believe we're going to see not only availability, but also inventory of them and price points starting to come down. Alex, question for you. Can your tools function in both a 100% OpEx as well as a hybrid type of a model? I mentioned how Tech Mahindra provides the ability to do 100% OpEx or a split. Can you address that?
Yes, sure, Ken. Yes, you'll be able to select that option in the inputs selection. If you wanted to deploy it on-prem, you can deploy it on cloud. You can deploy it as pay-as-you-go as well. Depending on how you wanted to bill your customers, you can bill it on, for example, on pay-as-you-go based number of small cells, based number of devices, or based on number of bandwidth, like a gig and a gigabyte. So you have that option in our tools. You can do it CapEx and with OpEx, or you can do it fully OpEx as well.
Okay, great. Are you moving outside of CBRS for your business case tools, Alex?
Yes, yes, we are. We are looking at again as more like a global spectrum, so we can provide our tools to anyone in the world looking to deploy this private 5G networks. So it will be, if they want to deploy low band, mid band, high band, they can select that spectrum in our tool, and the tool will calculate the number of small cells required for that spectrum in that country.
Okay. Yes, of course. We've mentioned a few times we're going to be sharing the presentations as well as webinar recording. I see you joined a little bit late, Nitin, but yes, we will be sending that out to everybody. I got a question on COAI versus BIF. What I would suggest is you get in touch with us for that. I don't think we're prepared to go into having a full opinion on that particular item today. And I guess we'll see if we have anybody else coming in with any other questions here. We've got about a minute left. Respectful of everybody's time and appreciate everyone joining today.
Ken, can I ask you one question before you end?
Sure, absolutely. Thanks, Alex.
So what type of wireless spectrum bands are suitable for private 5G networks? You think the licensed spectrum, shared spectrum, or unlicensed spectrum?
Yeah, thanks, Alex. Was trying to touch on that a little bit earlier, but a lot of it again goes back to what country you're based out of and what's available. I believe we've grown to about 10 countries globally that either have unlicensed or shared spectrum available for private 5G. That clearly will dictate how the deployment can proceed and whether or not a mobile network operator or owner of that spectrum needs to be involved to effectively sublicense it or let it to be used indoors. In the United States, we've got a combination of partners at Tech Mahindra. We can either operate in the CBRS environments with shared spectrum, a number of solutions for that. And we also have a licensed spectrum partner that we can work with to bring licensed spectrum, including millimeter wave, into the environment. I believe it depends on your use cases. It depends on your location and who the solution providers are. And when you work with Tech Mahindra, you have a number of options in those areas.
Thank you. Thank you, Ken.
All right, very good. Well, great dialogue. Thank you for those who provided questions. Alex, thank you again for joining and collaborating on this. We will share our email addresses on the version of the slides that you get sent to you. And we appreciate you coming and joining us today and your insights and helping us to put together this information sharing session for you all. Thank you and have a good day.
Thank you, Ken.